So this video is on factoring. So again, this is going to be on factoring. I'm going to go through a couple different situations. So first situation, let's say that we are starting with something like 6x minus 12. So on something like this, what we want to do always is ask ourselves, can we factor something out of everything? And from both of these, I can factor out a 6. And when I factor out a 6, I'm really like dividing each term by 6. So I'm going to get x in my first term minus 2 in my second term, and that would be my answer. So let's try a couple more, a little bit more complicated than this, but similar. So let's say I have one that was 3x to the third minus 9x squared. So again, the very first thing I'm doing is I'm looking to see, can I factor something from both terms? First, I'm going to look at my numbers, a 3 and a 9. I can take a 3 from both of those, so I can factor out a 3. But then looking at my x's, I have an x cubed and an x squared. I can actually factor x squared from both of them. And then when I take 3x squared from 3x cubed, I'm left with an x minus. When I take a 3 divided 3 out of 9, I get a 3. And my x squared was divided out, so I just get x minus 3. And that would be my answer. Let's say one more like this. So let's say we have a 4x squared minus 12x. I am looking to factor again from my numbers, but also from my x's. So from my numbers, I can factor a 4 from both of those. And from an x squared and an x, I can factor an x. So I'm going to be left with x minus 3. And that is my answer. So now let's try ones a little bit more complicated that are trinomials. And I'll go through some different things. So let's say I have a trinomial like any of these four that has a lead coefficient of 1. So what I mean is I have just an x squared in the front, okay? Not a 2x squared or a 3x squared, anything like that. So these ones we can think of as diamond problems. And we want to basically think about what multiplies to the constant, which is 12, and adds to the x, which is 7. And so that's going to be a 3 and a 4. So my answer is going to be x plus 3 times x plus 4. It doesn't matter the order that I write those in. On the next one, if I do a diamond, I want it to multiply to negative 15 and add to a 2, okay, because of the x. And when I'm trying to think of something that multiplies to negative 15 and adds to 2, because it's negative, one of them is going to be positive, one of them is going to be negative. The bigger number is going to be the positive because I have a positive 2. So what multiplies to negative 15 and adds to a 2? 5 and negative 3. And so my answer is going to be an x plus 5 and an x minus 3. When I am looking at one like the next one, I have a positive 16 I need to multiply to. Again, it's always the constant goes on top. And the x, which is a negative 10, is going to go on bottom. When I have a positive product, either both of them are positives or both of them are negatives. So since I have a negative sum, these are both negatives. So that means I'm going to have a negative 8 and a negative 2. So this is going to be x minus 8 and x minus 2. The next one here, a negative 14 has to multiply negative 14, add to a negative 5 again. It's a negative, like the one above it, for the product, which means one of them is going to be positive, one of them is going to be negative. The negative is going to be the bigger one because my sum is a negative. And that's going to be a negative 7 and a positive 2 that multiply to a negative 14 and add to a negative 5. And so this is going to be an x minus 7 and an x plus 2. Next, we're going to try ones with a number in front. So let's say that we have ones with the least coefficient other than 1. So let's say we have a 2x squared minus 5x minus 3. So for these, what we are going to be doing right now is we're going to be doing boxes to diamonds. So we're going to put our 2x squared here and our constant -3 here. And we're going to multiply those together and we get a negative 6x squared in that diagonal. And this negative 5x is going to be split here and here. It has to also multiply to negative 6x squared. So I need to figure out what will multiply to a negative 6x squared, but add to a negative 5x. And that is going to be a negative 6x and an x. So I'm going to put in a negative 6x, makes it a little bigger, and an x. And then I want to find the outside. I always start with trying to find look, my 2x squared. So that's going to be a 2x here because of the 6 at the top and an x here. And x times 1 gives me that x. 2x times a negative 3 gives me the negative 6x. So my answer is going to be 2x plus 1 times x minus 3. Okay. So let's say we try another one. Let's say we have a 6x squared plus x minus 15. So again, I'm going to do my box. I'm going to have a 6x squared here and a negative 15. And I'm going to multiply those together. And when I multiply those together, I get a negative 90x squared. And it has to add to this positive x, which means, oops, I'm going to put the x down here. Now, I can sit here and go through the list of things that multiply to 90, but I need them to be 1 apart. So I'm thinking a 10x and a negative 9x. And so one of these is going to be a 10x and one of them is going to be a negative 9x. And again, if you can't think of what goes in, what multiplies to 90 adds to 1, because it's a negative product, they're really going to be subtracting to 1. So you can just go through and go, okay, 1 times 90, 2 times 45, 3 and 30. And 4 is not going to go into 90 evenly. 5 does go into it. It goes in 18 times. 6 goes into it 15 times. Okay. And let's see, 7 doesn't go into it. 8 does not go into 90. 9 goes into 90 10 times. And so forth. And then I'm looking for one that has a difference of 1, and here it is. Okay, so that's one way to go about doing it. Okay, so now that I've found what it is, again, I'm going to find the outside. Now, a 6x squared could be a 6 and a 1 or a 2 and a 3, but seeing the 10 and the 9, 6 is not going to 10 or 9. So I know it's not going to be a 6 and a 1. So it's going to be a 2, which will help me get the 10, and a 3 that'll help me get the 9. 3x times a negative 3, 2x times a positive 5. So I'm going to get a 2x minus 3 and a 3x plus 5. And that would be my answer. Okay, I'll do 2 more like these. So let's say I have a 6x squared plus x minus 2. And I'll just write out the other one. Let's say 8x squared minus 6x minus 5. 8x squared minus 6x minus 5. Okay. And I'm just going to split that. Okay. So for this first one, I am going to do a box to diamond. I'm going to put my 6x squared here and my negative 2 here, which is going to be a negative 12x. and it has to add, sorry, negative 12x squared, and it has to add to 1x. So that will be a 4x and a negative 3x, because those multiply to a negative 12 and add to 1. So I'll put 4x here and negative 3x here. And then I'm looking at the 6, which could be a 6 and a 1, but with a 4 and a 3 for my x's, that's not going to work. So I'm going to have a 2x here helping get the 4, and a 3x here helping get the 3. So minus 1 is 3x times a negative 1 gets us a negative 3x, 2x times a 2. So my answers are going to be 3x plus 2 times 2x minus 1. Okay, in the next one, again, box to diamond. Now, always my first step would be to see if I can factor something out of every term. These ones I cannot, so I didn't really talk about that in these, but I really should always look to make sure I can't factor something out of every single term. So this is going to be a negative 40x squared when I multiply it. It has to add to a negative 6. I'm thinking a negative 10x and a positive 4x. So I'm going to have a negative 10x and a positive 4x. So my 8 could be an 8 and a 1 or a 2 and a 4, but with the 4 and the 10, I think it's going to be a 4x and a 2x. 4x will help me get the 4x and 2x will help me get the 10x. So 4x times 1 gets us a positive 4x. 2x times a negative 5 gets us a negative 10x. So I'm going to have a 2x plus 1 and a 4x minus 5 as my answer. So now I'll do two special ones, the difference of two squares and a perfect square trinomial. So for a difference of two squares, when we're dealing with this, a squared minus b squared is what we're looking for, a square minus a square. And so I take the square root of the front, which would be an a, and I would put that in both parentheses. I take the square root of the back, which would be a b. One's going to be a plus, one's going to be a minus. Again, this is called difference of two squares. So when we're looking at this, we're trying to decide, okay, what am I squaring to get these things? So for x squared minus 64, the square root of x squared is x. So that's going to go in front of both. One's going to be a plus, one's going to be a minus. The square root of 64 is 8. One's going to be a plus, one's going to be a minus. And that's my answer. Okay, I don't have a middle term because if I was to multiply this out, I get a positive 8x and a negative 8x, which cancel out. And that's why I don't have any x term. On 9x squared minus 49, the square root of 9x squared is a 3x. And then I'm going to have a plus and a minus. The square root of 49 is a 7. So I'm going to have a 7 and a negative 7. And that's my factors. On one like 4x squared minus 25, same idea. The square root of 4x squared is a 2x. The square root of a 25 is a plus 5 and a minus 5 to get the middle to cancel out. Now, this one, anytime you have an exponent that's even, it is a square, because if 2 divides into that exponent, it would be a square. So this is really an x squared being squared, and this is a 4 being squared. So if I work this out, I would have an x squared plus 4 and an x squared minus 4. Okay, because again, my x to the fourth was an x squared being squared. Now for this one, this x squared minus 4 is another difference of two squares. Sometimes that happens when you have like maybe an x to the fourth and you break it down to an x squared, depending on if your square root is another square. So this is going to stay x squared plus 4. I cannot do the one with the plus. And my x squared minus 4, the square root of x squared is x. I'm going to have one that's a plus and one that's a minus, and it's a 2 because the square root of 4 is 2. And again, this was my x squared minus 4. And then I'm going to do an example of perfect square trinomials next. So these are the formulas for perfect square trinomials. If you have a square in the front and a square in the back, maybe they are perfect squares. So if you have a situation where you have an a squared plus a 2ab plus b squared, then your factors are a plus b quantity squared. Or if you have an a squared minus a 2ab plus b squared, then again, it's a perfect square it's a perfect square trinomial, a minus b squared. So what you want to do, how you recognize this, is you want to look at the front and say, hey, that's a square, and this is a square. So maybe, again, I'm saying maybe it's a perfect square trinomial. So what's the square root of 4x squared? 2x. And it would be a plus because that's a plus here. Okay. What's the square root of 9? 3. So I need to check. I can't just assume because I take the square root of the front and the back that I will necessarily get that middle term. So how do I check to get that middle term? I basically multiply these together, which would be a 6x, and then I double it because see how this is multiplied together, and then I double, okay? If I multiply this, I get I'll write it, but this is not part of my answer. I get a 6x, and then if I double that, I get a 12x. That means that that was a perfect square trinomial. And so my answer is the 2x plus 3 quantity squared. Okay, on the next one, I take the square root of 9x squared, which is a 3x, a minus because of that minus there. I take the square root, and again, I'm looking at the front term being a square and the back term being a square with a positive. Has to be a positive. And then I take the square root of 9x squared, which is a 3x, a minus because of the minus right there. The square root of 25 is 5 squared. Now, this might be my answer. This might not be my answer. I need to check and make sure that I get this middle term. And I check by multiplying this together, which would be a negative 15x, and then doubling it, and I get a negative 30x, which is what I had. So that is our perfect square trinomial. And so that is our answer. The last one I'm going to talk about is sum and difference of two cubes, okay? So if you have an a cube plus b cube, like I have here at the top, what you're going to do is you're going to take the cube root of the first term, which would be an a, plus the cube root of the second term, the b cubed, which would be a b. Now, what I'm going to do is I am going to look at this a, okay, whatever's here, and I'm going to square it. So that's going to give me an a squared. Then what happens is this minus, this plus, whatever sign that is, this is going to always be opposite. That's the formula, okay? I'm not proving it, I'm just using it. Then whatever is here, which is in this case is my b, I'm going to be taking these two things, okay? I'm going to be taking this a and this b, and I'm going to be multiplying them together, and I'm going to get an ab. This is always going to be a plus because what I'm going to be doing is squaring. Get rid of this. I'm going to be squaring my b. And when I square that b, I am going to get a b squared. That is my answer. Okay. Now I'm going to go through and do the same idea with the minus. So I take the cube root of the first term, which is going to be an a minus because of the minus, the cube root of the second term, which would be a b. Okay, that's my binomial. Now I'm going to get a trinomial. So now I'm going to be focusing on my first term, and I'm going to be squaring that. Then whatever sign is here, it's going to be opposite here. So that's going to be a plus. Then I'm going to multiply these together, ignoring the sign. I get an AB. Then I'm going to be squaring this term, and a negative b squared is going to be a positive b squared. And again, this is called sum and difference of two squares. Not squares, sorry, 2 cubes. And we're just going to use this formula. So for example, I guess I don't need to write that. I'm going to do, let's say, 27 x to the third plus 125 y to the third. Okay, so both of these are cubes. So what I'm going to do is I'm going to take the cube root of both of these. So what am I cubing in the first term? Really a 3x. That's what I'm cubing. Plus, what am I cubing in the second term? A 5y. So first thing I do is I take the cube root, okay, the thing that I'm cubing to get my 27x cubed, which was my 3x, plus what was I cubing to get the second term? 5y. Okay, now I'm going to focus on my 3x, okay? And on my 3x, I'm going to cube that, which is a 9x squared. Then I am going to look at this sign, which is a positive here. Now it's going to be the opposite. It's going to be a negative. Then I'm going to be multiplying these two terms together. Sorry. Multiplying these two terms together, which would be a 15xy. I already decided the sign, okay? Then I am going to square my 5y, which is going to be a 25y squared. And this is my answer. This is my answer. So let's say I try another one. Let's say I have an 8x to the 6 plus a let's say a 343 y to the, sorry, I keep on moving that. A 343 y, and actually I'm going to make it some minus, make a minus this time. Y to the 15th. Okay, let's say we have something like this. So again, I want to figure out, hey, what am I cubing? So my 8 would be a 2 cubed. My x to the 6, if I divide my exponent by 3, I get an x squared. So I was actually cubing an x squared, okay, minus, and my 343, okay, if I take the cube root of 343, that is going to be a 7. And then if I take my y to the 15th and I divide it by 3, that would have been a power 5 that I was cubing. Because when I do these, power to power multiply. So those would multiply to the 6. 5 times 3 multiplies to 6. So if 3 times something gets me the exponent, it is a cube. Okay. So now what I'm going to do is I'm going to take what I was cubing, which was a 2x squared. That's going to be my first term, minus. I'm going to take what I was cubing for the second one, which was my 7y to the 5th. And now I'm going to focus on just these. So my 2x squared, I'm going to square that, which would be a 4x to the 4th. And then this is a minus, so this is a plus, always opposite. Then I'm going to be focusing on just my 7y to the 5th. Actually, well, before that, sorry, I'm going to be multiplying these together, which is going to get me a 14x squared y to the 5th. Again, I don't look at the sign because I already decided it was going to be positive. Then I am going to look here and square this. And when I square that, I get a 49y to the 10th. And that's going to be my answer. So again, I take this 2x squared, I squared it. Then I multiplied these together. That's how I got this. Then I took this last term and I squared it. And that's my answer.